Hello everyone, in this video I'm going to discuss the example for the topics limits. Find the vertical and the horizontal asymptote given that the function equals to x plus 3 over x squared minus 4. So step number 1, we're going to find the domain. So how to find the domain? Kindly observe the function. We have the numerator part, which is a linear, so the domain will be negative infinity until infinity. Then for the denominator, it is a quadratic. As we all know, the quadratic, the domain will be negative infinity until infinity. But for this case, the quadratic as a denominator, so x squared minus 4 cannot be equals to 0. So if we factorize the situation, we will have x minus 2, x plus 2, which is not equals to 0. So x cannot be equals to 2 and x cannot be equals to negative 2. So based on this part, the domain will be negative infinity until negative 2, union negative 2 until 2, union 2 until infinity, where the negative 2 and 2 is not included. As for this case, we have two domains and the operation is intersection. So now we have to denote the situation in the number line. So where we have negative 2 and 2. For this case, the situation is all real number. And for this case, we denoted it as empty circle for negative 2 and also 2. And then we draw a line connected the empty circle. So intersection. So the situation will be this part, except negative 2 and also 2. So as a conclusion, the domain would be negative infinity until negative 2, union negative 2 until 2, union 2 until infinity, where negative 2 and 2 is not included. Step number 2, vertical asymptote. So in this case, kindly refers to the domain. We have two vertical asymptote, which is x equals to negative 2 and x is equals to 2. Step number 3, we're going to study the behavior. So, have a number line. We have negative 2 and 2. Let's suggest a value for each part. So, for the negative 2 from the left, we have negative 2.0001. As for the right, we will have negative 1.999 and 9. As for the 2 from the left, we will have 1.999 and 9. As from the right, we will have 2.0001. This will be the suggested value. So now we are going to study the behavior. First, limits when x approaching negative 2 from the left, and limits when x approaching negative 2 from the right. Substitute the function. We have x plus 3 over x squared minus 4. So in this part, my suggestion would be substitute the simplest form, which means x minus 2, x plus 2. Another part, x plus 3 over x minus 2, x plus 2. So now we are going to discuss. So, for this case, we have to make use of the negative 2.0001. So, if we substitute this value into this part, very obvious, we notice that we will have a positive value, and if we substitute into this part, we will have a negative value. Followed by, if we substitute into this part, again, notice that negative 2.0001 plus with 2, we will have another negative value. So finally, limits when x approaching negative 2 from the left for the function x plus 3 over x squared minus 4 will be equals to positive infinity. Meaning that the function f increase without limit when x approaching negative 2 from the left. Next part, we are going to focus on this part. If we substitute the value negative 1.9999 into this part, and we will have a positive value for the numerator. Then let's have a look if for this part, again, we will have another negative value. If we substitute into this part, and we notice that 2 is greater than 1.9999. So now we will have a positive value. So limits when x approaching negative 2 from the right for the function x plus 3 over x squared minus 4, we will have a negative infinity. Meaning that the function of f decrease without limit when x approaches negative 2 from the right. So that would be the vertical asymptote. X is equals to negative 2. So now I'm going to discuss the behavior when x approaching 2 from the left and from the right. So repeat the situation. Limit when x approaching 2 from the left. Limit when x approaching 2 from the right. Kindly substitute the function x plus 3 over, do remember, pick the simplest form, so we will have x minus 2, x plus 2. Repeat the situation. So x minus 2, x plus 2. So now let's refer to the left hand side. We have negative 1.999 and 9. So if we substitute, for sure we will obtain a positive value over. What if for this part, negative 1.999 minus 2? Very obvious, it is a negative value. If for this part, I'm sure we will have a positive value. So limits when x approaching 2 from the left for the function x plus 3 over x squared minus 4, we will have a negative infinity. Meaning that the function of f decrease without limit when x approaches 2 from the left. Let's move on to the right hand side. So the value would be 2.0001. If we substitute, we will have a positive value over. For this part, very obvious, 2.0001 more than 2. So again, we will have another positive value. Multiply with positive value. So at the end, limit when x approaching 2 from the right for the function x plus 3 over x squared minus 4. and we will have a positive infinity, meaning that the function of f increased without limit when x approaches 2 from the right. So the vertical asymptote in here would be x is equals to 2. Step number 4, we are going to find the horizontal asymptote. How to find the horizontal asymptote? Kindly write down the situation. Limit when x approaching negative infinity. Another part, limits when x approaching positive infinity. Kindly substitute the function. What we have, x plus 3 over x squared minus 4 for both cases. Next, we are going to substitute the value, and we will have negative infinity for the numerator and positive infinity for the denominator. So in this case, we denoted it as IDF or indeterminate form. So now we have the IDF. So what is the strategy to solve this kind of problem? Dividing the numerator and the denominator by the highest power of x for the denominator. So kindly reverse the denominator. We have the highest power is x squared. So now limits when x approaching negative infinity, x squared bracket 1 over x plus 3 over x squared over x squared bracket 1 minus 4 over x squared. Simplify the situation and we will have limits when x approaching negative infinity 1 over x plus 3 over x squared over 1 minus 4 over x squared. Do remember the key. 1 over infinity we will have 0. So if we substitute we will have 0 for this part. Again 0, 0. So as a conclusion 0 over 1. So we will have 0 as a vertical asymptote. Same goes to the right hand side. Limit when x approaching positive infinity. So here repeat the situation, we will obtain 0, 0, 0, and finally we will have 0. So the horizontal asymptote is y equals to 0. So here we are, and thanks for watching.